Hey robot makers, hope you're having a good day so far. So do you want to learn how to communicate with Bluetooth between a Raspberry Pi and a Pico W, in fact any kind of MicroPython device that has Bluetooth on it? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our slides. So yes, this is all about Bluetooth, following on from last week's Bluetooth show where we looked at how to communicate between two Picos using Bluetooth. So I thought this would be quite an interesting one. I didn't find a lot of information online about this, so I thought it'd be quite a useful thing to do. So following on from last week's show where we connected two Picos together with Bluetooth, I thought this time let's try a Raspberry Pi. I've got a Raspberry Pi 5 on my desk. It's any Raspberry Pi that has, I think it's 3 up, that has Bluetooth connectivity on it. I'm going to communicate to a Pico, but it could be any device that's got Bluetooth on it that's running MicroPython. I've also improved the code since last week, so we'll have a look at what that is in sort of a lesson 2 of 3 today, and we'll also have a temperature sensor example as well to show how this could work as a proper kind of Bluetooth peripheral. And if you want to play along, there's a repository that I've saved online at GitHub, and the link to that is in this link on screen now. So kezrobots.com/blog/pi-2-pico-bluetooth.html. So if you follow along with that, you can play with the code yourself. Okay, let's get straight into the sponsor for today's show, which is PCBWay. So they've been sponsoring quite a few shows that we've done in the past, and they've decided to sponsor this one as well. So I've got a couple of PCBs I recently got through them. So this one is the Gamepad 2. So I've actually got a fully working version of that on my desk as well. So this one has the Raspberry Pi W just behind there. You can see, probably see a bit of a, I've not cleaned this one up yet, it's got a bit of flux on it still, but this one is a fully working one, and this one has a little screen on it. It's got 8 buttons for direction and 3 buttons for the menu as well. It's also got a little power connector down there as well. So they've been helping out with these, and I'm going to show you very quickly how we do that. So if I jump over to here and I go over to the tab that has PCBWay on it. So what I did on this one, I think these were I'm going to say, was it 150 by 100? So if I do, the length is 150 by 100. That's the sort of panel size. It's just a 2-layer one. And I think I just bought in fact I got a quantity of 10 for this particular project, because I thought I'll probably use quite a few of these, so got a whole bunch of them. So on the it's a single panel design, 150 by 100, and I went for 10. And then I can simply just accept everything on there. I think I went for a black solder mask on there, so you get that nice kind of black colour. You can also go for like lots of other colours. That was the yellow one, for example. That was the previous version of this particular project. And then if you just do a calculate on there, it'll give you a very quick price, and that's what you're going to pay. So for this one, for 10 panels, it's $44. Let's have a look. In fact, was it 150? That seems quite high. I'm going to try 15 by 10 millimeters. That also doesn't seem right. So what I'm going to do, I'm just going to change that to 5. Let's make that back to that and recalculate again. They've got 34, and we can see there that's the build time, 3 to 4 days. You can change that as well as you like. Once you're happy with that, you can just save the cart. You can then upload the Gerber files. So I use Fusion 360 to design these. We'll probably do this on next week's show, and I'll show you all about this particular project as I've got it paired to a robot that we can control. And then in a couple of days time, so it's 3 to 4 days to build that particular one, a couple of days for shipping after that, so give it about a week, and these arrived, and yes, I was up and running. A couple of other projects I've done recently as well is I've got these little servo helpers. Let's go full screen on that one. Go full screen on this one. So these little servo helpers, I've got a whole bunch of them, and these simply allow you to connect regular hobby servos, connect the GPIO pins at the top, and then you can just share the power from an external power source as well. I'm always needing things like this. These are an upgrade from the previous one that only had about 6 on there, and these are now all, the pitch is all the same, so you can just put 4 header pins on there and you're good. So thank you very much PCBWay for sponsoring today's show. Okay, let's get back to our notes. And yeah, so we're going to be looking at Bluetooth on embedded devices. So last week we did this Bluetooth to Bluetooth communication, and MicroPython has that Bluetooth support built right into the firmware. So when you flash MicroPython to your device, if you have the radio on there, if you've got the Bluetooth chip on there, it's on the Pico, it's the one with that little silver encasement there. That means that the Python has Bluetooth already ready for you. And that makes it really easy and quick to get up and running, and reliably so as well with MicroPython. And interestingly, that's not the case with standard Python. So if you've got a regular Raspberry Pi and you're running regular Python on there, you have to install libraries to be able to use the Bluetooth. And that came as a bit of a surprise to me. You would have thought that that's quite a modern thing, but no, it's an extra thing that we have to add on. So how do we do that? So that's one of the challenges. It's not built in like on MicroPython devices, and that's probably because there is lots and lots of different radios out there that broadcast with Bluetooth, and we would have to have a library that works for each of them. So there needs to be some kind of middle layer that works with this. So if it's running on a Raspberry Pi, then there's only so many different Bluetooth radios, if you like, on there, the Bluetooth chips that are on there. So we only need to have a couple of libraries that work with that. Now, one of the cool libraries is BlueZ, or Blues. That's a very common one. And there's also Bleak, which is the Bluetooth low energy version. That's what we're going to be using today. I actually think that Bleak uses Blues in the background as well. So that's what we need to install on our Raspberry Pi to get that up and running. So we're going to have a look at that in a second. So let's have a look at what possibilities we can use with this. So you can see there I've got the I was just running a little demo program on my gamepad there that I created. So we can create Pico based sensors. We'll create one of those in lesson 3 in a second or two, a couple of minutes time. We can create multiple sensors with caveats I discovered later on. We'll get into that. And we can control a robot. So my BurgerBot that I created about 2 years ago, that can be controlled with in fact, the very first version of the gamepad that I created, this yellow one. So the updated version that now has the screen on it, we'll be able to actually see what commands we're sending and receiving to our robot. So we can set that up so that the Pico is the robot and the Pi is the controller, or the Pi is the robot and the Pico is the controller. We can do it whichever way we wish. And the Pico remote to the Pi robot, that's the setup that I'll be looking to do probably for next week's show. Okay, so let's jump into some code. So again, if you want to play along, I'll put a link in the description to the code for this particular one, but it was just at the very top of the show there. I did have a link on screen for it as well. Okay, what I'm going to do, I'm just going to go to me for a second while I just rearrange my screen, and we can see on here what we are doing. Right. Okay, so just for information, what the setup is you're seeing on the screen. So I have a Raspberry Pi next to me. If I go to this view over here on my desk, I've got this Raspberry Pi 5 here, and I've also got a little Pimroni Explorer, one of the first ones that they did, with a Raspberry Pi PicoW connected, and they're both connected by a little cable, just so we can upload code, but they will be communicating via Bluetooth today. So that's the hardware setup. And if I go back to the screen here, I'm communicating over the internet to this Raspberry Pi using their connect.raspberrypi.com. So free piece of software, free service. It's a bit like VNC. You can just see in the top here we've got this screen being shared and so on. That's just how I'm controlling it and then broadcasting it out to you. Okay, so if I go to the repository where I've already cloned the code, you can see there we have lesson 1, 2 and 3. So I'm going to open up lesson 1. And I've got two files in there. We have PicoA and we have Pi_demo. So PicoA is the code that I'm going to be running on the Pico. So I'm running this in Thonny just to differentiate this, and we'll go through that code in a second. And this is pretty much verbatim the code that we created last week, if you're interested in a more deep dive on that. I've also got Visual Studio Code, and if we go to lesson 1 and the Pi demo one there as well, or Pi demo, this is the code that we're going to be running on the Pi. So I'll go through that code to show you how that works in a bit more detail. So let's do that. I'm just going to hide that tree view there, and I'm also just going to hide at the bottom of the screen here this sort of terminal window. We don't need to see that just yet. Right, so this code we created just for the Raspberry Pi. I call it the Raspberry Pi 5, but it works on, as I said, any Raspberry Pis that have the Bluetooth chip on there. So we're importing async IO. That's because we're going to be doing some asynchronous input-output via the Bluetooth. We're going to be using the Bluetooth low energy library that's called Bleak. So we'll have to do a pip install Bleak in our virtual environment. there's a bit more of a write-up on the tutorial for this that's online if you want to see exactly the step-by-step on how to do that particular thing. But if you followed along on previous shows, you should probably know how to do that by now. What I've also done on here is I've put the MAC address of the Bluetooth device. So just like a regular network card, if I have I got a network card I can show? Probably not. When devices communicate, they usually have an interface to do that communication through. And if it's something that can use TCP/IP, if it's something that's a physical connector rather than like UART, I'm trying to describe how, trying to think about how best to describe this. If it's a Wi-Fi connection, a Bluetooth connection, or a physical Ethernet connection, they usually have a MAC address. This is this, what does it stand for now? Machine Address Connection, something like that. I'll Google it because I can't remember what it actually stands for. It stands for, let's see what that comes up with. Sorry, Media Access Control address. So a MAC address is a media access control. Every device has a unique MAC address. So every Bluetooth chip, every iPhone, they will have multiple because they've got multiple radios in there. Your Mac computer, your Raspberry Pi, they all have absolutely unique MAC addresses globally. No two have the same. And that means that we can rely on that as a unique identifier. So if we want to communicate from one device to another, there's a number of different ways that we can do that. And one of the simplest ways is to know what that MAC address is. And I'll show you the code how to get that shortly. And they look like this. They have 6 groups of 2 bytes. So D8 is 2 bytes, 3A is 2 bytes. Let me just move that little cursor out of the way there. And DD is 3 bytes and 2 bytes and so on. So I ran some code to figure out what this MAC address is, so I can then say specifically only talk and only look for this MAC address. So that's the MAC address of the PCBWay that we have connected in there. Okay, next up we need to have a couple of characteristics. We've got the service universally unique ID, UUIDs, and we also have the characteristic universal ID. So these two are just ways of communicating what the service is at the top level. If you remember last week's show, we have the service, and the service can have many characteristics. And the characteristic we've got there also just has a number in there that's it's almost like the channel that we're speaking on. Okay, so next up we have the connect and communicate piece. So I'm just going to scroll the code down here a little bit, if it'll let me do that. So this is an asynchronous function. That's again just that little async keyword that's at the beginning of the code there. That makes this function be able to run at any point rather than just the normal kind of structure of a code. It can run as code is called externally to it through the Bluetooth. So connect and communicate, it says connecting to address. We're going to pass in an address. I knew it'd start doing this disconnect thing. It's fine, we'll be able to just connect back to that again. There we go. And then we've got this while true loop. So this is going to run forever. So once we've made a connection, so this async with bleak client address as client means that we're going to use the bleak client. That's going to use the address that we're providing it, which will be that Pico address we provided earlier on. And then we're going to refer to that connection as client. So anything that says client dot is basically using that Bluetooth connection. So we can then say print connected, client is connected. So it should just give the connected is true kind of message. And then, so this while true loop then will just carry on working forever. So we've got a message there that says hello from Raspberry Pi. So this is going to be run on the Raspberry Pi, sending out to the Bluetooth device. So we should be able to receive that on the PCBWay, and it should say, received message hello from Pi. So that's how we know this will be working. We're going to print out sending message. We're going to send that message then, and then that await client.write GAT car. So GAT is the characteristics being written onto the Bluetooth device. To that particular channel, which is the characteristic UUID, and then the message that we've just created there, which is that hello from Pi. We've got this dot encoding UTF-8. The encoding is just a way of making sure that the text string is like a valid text string. It hasn't got any kind of weird characters in it or anything like that. So that's just a way of making sure that we can handle that and send it backwards and forwards. Once we've written that, we're then going to read a response. We say response equals await client.read GATS car, and that's the characteristic ID that we want to listen on, again the same channel, and that will create a bit of a problem that we will look at and fix in the next one. But something we spotted last week. And then we can print out the message received, and then we can say in these little curly braces, because it's an F string, we can say response.decode UTF-8, and that will decode the message that's been sent in to us and make sure it's valid text, because I think they get sent as like a byte array, which is very slightly different than a text. And then we just wait for a second, just so that the text doesn't scroll too quickly off the screen. We can at least see one message coming in a second. So that's the connect and communicate. I think that, yeah, that's pretty much it. And then this is as much as there is to this code. It's really, really simple. We then got a loop equals async.get event loop, and then loop.run until complete. So it's just going to run once. Once it's sent that message, it's gonna quit. So you can see there, connect and communicate. Oh yeah, so there we go. And then we pass in that Pico address that we defined at the very top. Now if we look on the Thonny code, let's go back over here. So this is the same code that we created last week. So we have AIBL, which is the asynchronous I/O for Bluetooth Low Energy. We've got the Bluetooth, which handles all the Bluetooth connectivity on the PicoW through MicroPython. We've got async I/O for doing asynchronous I/O. Struct is just a way we can pack and unpack strings if we need to do that. And this sys input exit is just, we want to exit the code if we don't set IAM to be either peripheral or central. Again, if you want to know what that's all about, have a look at last week's show, Pico to Pico communication. So we've got a piece of guard code there that just checks to see if IAM is not either peripheral or central. It says it must be either of those, and then it quits. And it's just to make sure we don't try and run the code without it being either of those. You can just comment or uncomment these as you need to. If it is central, then we're going to send to the peripheral, otherwise we're going to send to the central, and this is just the different roles that they have. So in our case, we're going to be doing the role as a peripheral. We're going to be sending, waiting for messages to come from the central, and then we're going to send responses back. Okay, so the message that we've got there is simply just hello, it should say I am peripheral. We've got a whole bunch of Bluetooth parameters. I don't actually think we use them. We should have done, but we don't, so I probably won't go over them just now. We've got a message count variable just so we can increment that to show the different messages that are being sent. Again, it just helps with debugging to see that that's changing, because you've got that little shell window at the bottom of the screen there, and if the same message goes up many times, you can't actually see that that's moving. It just looks static. So by having a counter added to the end, it just makes that easier to debug. We've got two functions, one for encoding and decoding, and they just do that. We could have simply just put message to encode and decode within our code. This is a little bit over-engineered, but it is what it is. It means I can put print statements and things in there if I want to understand a bit more what's going on there. Then we've got two functions, one for sending data and one for receiving data. So these ones check for a connection, check that it's the right characteristic, the right channel that we're going to be speaking over. They're going to set the message to be whatever the message is plus the message count, and then they're going to increment that message count so the next time it runs it's a higher number. We print out what that message is just so we can see that on the console, and then we've got this try except block. So this is going to encode that message, just call it MSG. We're then going to write that message to the characteristic. We're going to wait for half a second. We're going to then read a response. We're going to decode that message from the characteristic we just read in, so response will have whatever has been sent back to us, and we can print out I am sent. And remember that's going to be the peripheral sent the message, and the response was whatever we got back from the central. Otherwise we can just print out that there is an error message, writing error, and so on. There's another block of code. I don't think do we use this one? Possibly not. So we've got a receive data one. This one just awaits for data to come in from the device. If we get data, we can print out, oops, that went a little bit too far then. Kind of skimming over this simply because we went through this quite a lot of detail last week. I want to get to the bit where I actually show you this running. And then we've simply got a piece of code there, run peripheral, which is what this is going to be. So we set up the Bluetooth service there, we set up the characteristic, we have write enable there, write is true, that's one of the important bits. And then we register that service that we just created there. Print out that we are starting to advertise. This is how Bluetooth devices advertise out their services that are available. And while true, we can just say sync with await advertise, able to advertise. We pass in all the parameters that we set earlier. We print out connected to another device. This happens after we've connected. And we can say the connection.device. We can see the address or the unique ID that's coming from. And then we create a task that simply send data. We pass in the connection and the characteristic. And then we just gather those tasks. We can have more than one task in that queue, and it'll run them all asynchronously at the same time. And then we just say disconnected after that quits. So it'll keep doing that up until that point. So once the tasks have all finished, it'll say I'm disconnected, and then we can break, we can quit out of that code. I've also got in here a little BLE scan function. That's just to scan to see what devices are available. I don't think we use that in this particular code, but that's in there if you wanted to see what other Bluetooth connections have you got in your area. And we've got this run central mode. We're not running that one today, so we can skip over that. And then we've got the main code. So, well, true, if I'm central, run this task. Otherwise, run peripheral mode, which is what we're going to be doing today. And it's going to do that forever until we stop it. So if I run that code, you'll see down here it says peripheral started to advertise. So until we get another device connecting to it, it's just going to sit there waiting for a device to connect to it. So if I now go over to our first block of code, which is this bleak one, this is going to send messages out saying -pi, and it's going to receive messages back from the Pico. So let's run this one. If I click on the run button there and I expand that terminal window at the bottom, you'll see there it says it's connecting to D8 3ADD. That's the MAC address of oops, so it timed out that. Let's just do that again. It's probably because I was stretching the screen. There we go, connecting. I'm just going to check on the Thonny there. That's waiting to advertise. We should see in a second that will show that it's connected, all being well. Now you can sometimes get a sort of flakiness with these things. I'm just going to stop and start that one again. I have seen this a few times, and I think it's just one of those things that can happen. We probably need a bit more error checking around these, a bit more try and catch clauses. And I tested this code out many times before the show, so it should work. But this is a live test, so you never know. Let's have a quick see what's happening there. So it's saying that there's a timeout error. Interestingly, it is saying it's that Blues is the library that's underneath the Bleak library, which is the low energy version. So I'm just going to double check what I've got there. So Pico A is the correct code, and PyDemo is also the correct code. I'm just going to try again. I'm going to try this a few times just to see if we get that to connect. It worked very reliably when I was trying this out before, so I'm not sure what's changed there. I wonder if it's actually the MAC address. So in the code, I do have I had two different devices that I was testing out. I'm just going to make sure it's the right one, because they did have they did have different MAC addresses. So D86C. So what I'm going to do to help troubleshoot this, in lesson 2 we actually have show Pico MAC address. If I just run this code, I'll go into this in a bit more detail in a second. We can see there, so D8 and it ends in 6C. I think that is the correct code that we're looking for there, D8 6C. So yeah, that really should work. I'm going to run this one first then, and then I'm just going to make sure we're running the other code. Maybe it was just the sequence that it wasn't happy with. Back to Pico A, run that. And we should see that connection come through if it's happy. Just thinking why else that could be that's not working. If that doesn't work, I'll have to push on to the next one and I'll explain. We can try that again later if that doesn't work. It's always frustrating with these live demos, because unlike an edited video, I could just keep doing this until it works, but this is live, so sometimes things don't quite work right. Okay, so let's move on to lesson 2. One of the issues with this previous piece of code was that we've got this kind of echo effect going on. So what was happening was both devices are trying to write to the same characteristic, and that means that sometimes you'll see the message come through saying -pi5. Other times you won't see that one. You'll just see the one that the Pico's sending back, and you think, why can it see the one it's sending as a response, and it's because there's like one buffer of memory, and either one's writing in or the other one's writing in, and if they both write to the same characteristic, you get that kind of overlay thing happening. So the solution to that is to have a receive and transmit channel. And that means that we can write to one and listen on the other one, we can listen to responses, and it's a way of separating them out, and they will never overwrite each other, because you're only going to write to one channel and listen on the other one, just like you would with a UART connection. You'd have a send and receive. So if we try that, that should be able to fix it up. So if you like these kinds of videos and you want to help me out, drop this video a like, leave me a comment, let me know if you've worked with Bluetooth, if it's any of the projects that you're thinking of working on. And if you are thinking about working on that, what kind of device are you going to connect to? Is it ESP32? If it is, what brand of that? I believe there's a new one that's come out. Is it a P4 or something that came out this week? And if you've not subscribed to the channel, also consider subscribing. It means an awful lot to me if you subscribe, and it helps to sort of grow the channel. So please consider doing that as well. I do go live every single Sunday at 7 o'clock, either Greenwich Mean Time or British Summer Time. We're still hanging on to British Summer Time now, even though it's now officially autumn. So we'll carry on doing this until that changes, and then it'll be back over to GMT, but 7 o'clock every Sunday. Okay, let's have a look at lesson 2, and hopefully that one will run a little bit better. So let's go back over to our code. Let's jump over to the Raspberry Pi Connect window. I'm just going to try running that one more time, just to see if that other code just decides to play nicely. Really frustrating when these things definitely worked before the show, and I've not changed anything around there. Can't think why that would be. That doesn't work. Okay, we'll move straight on to lesson 2. So what I'm going to do in the second block of code, I'm going to load up Pico A2, which is this one here. So this one has got an extra characteristic in there. So I've got a write characteristic and I've got a read characteristic. So the write is the one that we were using before. We created an extra one, and it's simply just 1 byte difference. So that one was E, this one ends in F for the unique ID. So we've got 2 different channels, one for reading and writing. So what I'm going to do, I'm going to stop the code that's currently running. I'm going to run this code. I'm going to go over to the Thonny. I'm going to load up demo 2. Let's load demo 2, and I'm going to run that, and then we'll have a look at the code if this works. If this doesn't work, that'd be quite frustrating as well. So let's see what's happening. I might actually give the Thonny a bit of a kick. No, there we go. So it's connected is true, and we can see there hello from peripheral, and we've got a count going up. If I go over to Thonny and we look on there, hello from central. So central is the full Raspberry Pi 5, and the peripheral is the Pico device. So the Pico is sending to the Pi, and the Pi is sending back. So you can see there hello from peripheral and hello from central. So that code's working. So we can have a look at that one in a little bit more detail. So I'm just going to stop that from running so we can see that in a little bit more detail. So here we go. So we've got those 2 characteristics, 6E and 6F. So if we come down to our code, pretty much everything's the same as we had before, apart from we have these write characteristics and we have read characteristics. So if you look, if I can get that to just sit in between there, we have write characteristics.write and read characteristics.read. So we only read to the reads and write to the writes, and that simply separates them out. And then on the Visual Studio side, on the Raspberry Pi 5 side, if we just move this code down so we can see a little bit easier, we've got the same 2 now. They are crossed over, so the read and the write, we want to use them in the sort of other way round. I'll explain that in a second as well. I've got a nice graphic for that. We can see there we're sending data, we're writing out to the write characteristics, and then on the receiving data, we get a response from, if I scroll right there, from the read characteristics. And that helps us just separate out those 2 areas of writing and reading. So it's a simple change to the code, but it makes it a lot more reliable. So we can run that one again. We can go over to Thonny. We can run that one again, and we can look at it from this side. So the peripheral is starting to advertise. So this is the Pico saying I'm available. I can do these things, this service with these characteristics. And on the other side over here, that one's getting a timeout now. That's funny. Let's try running it from there. I just wanted to sort of show you from the Thonny side as it connects. So it does seem quite hit and miss. I'm not sure what the issue there is. It's in the handshaking that seems to happen. So that one's just going to sit there. It's the Raspberry, the full Raspberry Pi running Bleak. I do believe that there is some quirks on how Bluetooth and Python work using this Bleak. It's not quite as slick as on the Pico, which is why this one, it worked 1 out of 5 times so far, I think. If we have this in a loop where it keeps retrying, I think that does actually work better. A bit frustrating that it's now not working at all on this one. We did see it working a couple of seconds ago. So I'm going to go over to lesson 3 now. We're going to improve this, and lesson 3 does have that retry code in it, so that we don't have to keep manually retrying it, and it does seem to make it that little bit more reliable. So I'm just going to make sure I've not missed anything on my notes there. So yes, a couple of things to note. On macOS, when you're using MicroPython, you've got those 2 times 6 bytes for the MAC address. On macOS, sorry, MAC address. MAC address and macOS sound very, very similar. On an Apple Mac, when you've got Bleak running, if you try and get the MAC address, it actually returns the unique ID, which is just weird. It doesn't do that if you run the exact same code on the Raspberry Pi. So it just makes developing things a little bit tricky there. And on the Raspberry Pi, it just shows the MAC address correctly, so you can get those 6 groups of 2 bytes if you want to specifically talk to a specific Pico. And we had a look about how to get that MAC address running that piece of code. I can show you what that is on Thonny. We can just have a quick look at that. So if I go over here, so we import Bluetooth, we create a Bluetooth low energy variable from the Bluetooth.ble class. We set it to active is true, and then we do 2 things. We don't need the first variable, so we can actually just use underscore because we never refer to it in our code, and that just means we have to accept it, but we don't need it. And then comma MAC address, that's the thing we are interested in, equals BLE config, and then we want the MAC configuration item from there. We then format this. This looks like a hellish piece of code, but this is how you used to do, or how you still do string formatting in Python. So formatted MAC address equals :.join, and then we have an F string. We have some bytes in there. B 2x is like get them in hexadecimal format. We've got those like FF, that kind of thing. And then there's a loop for B in MAC address. So for each byte that's in the MAC address. What we end up with is a nicely printable string. So if I run that code, you simply get Bluetooth MAC address for this device is D8:3A and so on. Everybody has a completely unique one. It's interesting, how do they do that in a factory? How do they make sure each one gets a completely unique address? Let you have a think about that. So that's how we get them. Was there anything else I needed to show in that? So yeah, I think it's just a lot cleaner, the code, when you've got this send and receive. Even though when I try and demo that to you today, it's been working honestly perfectly all afternoon. I'm just going to try that one more time for demo 2. You did see it working before, so we do know that it does work. I'm just intrigued to know why it's not working right now. It must just be something to do with it being a live stream. Yeah, there we go, it's timed out again. So now we're going to go over to lesson 3 now. So let's just go back to our slides. So one of the things we need to think about with our code is this 2-way communication is just like RX and TX, receive and transmit. We need to usually cross over those receive and transmits so that we only transmit, one transmits to the receive of the other and the other receives from the transmit of the other. So we have that kind of crossover, and that's what you do in UART as well, if you ever played with that with a Pico as well, if you're creating some kind of serial connection. So that's just something to bear in mind there. So I thought we'd do a real data example. So we passed across some like messages, but it doesn't really bring that to life. I can show you some examples of this working nicely if it runs at all. So let's update our example and provide a temperature reading from the Pico. So you may or may not know every Pico, including the ones without the Bluetooth chip on, have a little temperature sensor built into the core. So actually inside the core processor there's a little temperature sensor. We can take readings from that. Now they are a couple of degrees off what would be the regular room temperature, the sort of ambient temperature of the room you're in, simply because there's electricity going through this, it's doing work, and that generates heat. So the harder you push the chip, the hotter it will get. Only by a couple of degrees, so it's about 2 or 3 degrees out. So when you see the temperature readings, it isn't that hot in here. I think we're currently at, according to my air conditioner, 19 degrees. So if it says like 23 degrees, that's just because the chip's adding 4 degrees to it. So yes, this shows that we can create peripherals that can provide useful data, and we can receive that over Bluetooth. So that's what we're going to try and do in this lesson 3. Okay, let's get back over to our code. Let's go back over to here. Go full screen again. So I'm going to go into on here demo 3, which is here, and on the Thonny I'm just going to open up lesson 3 and Pico A. There we go. Just need to stop that code that's running. And then I'm going to run that again. I'll probably try quitting Thonny. Sometimes Thonny gets in a bit of a twist as well, which can not help. So I'm going to run that code there. I'm going to go over to Pi demo 3. I'm going to run this one. And let's see what happens now. So it says connecting to, and again, our D8, 3A, DD, 3E. There we go. Connected is true. And it says the temperature is 26 degrees. So it's obviously a bit more hotter in here. So if I go over to the Thonny, you can see it's getting a message back just saying hello from Central, because every time we get a reading in, we then can send one out as well. So I want to show you this is actually a live demo. If I go over to here, so you can see the code returning the temperatures. If I put my finger on the main chip, let's try and do that on here. Let's see if I can warm this chip up. So you can see it's gone to 27. Let's see if it's 27.5. Let's see if I can make it a bit warmer. So my body temperature is what, 37 degrees core. If I let go now, let's see if it'll drop down. So about 26.5. Bump to 27 for a second. 26.5 again. 27. So it's kind of bouncing around that temperature. Let's see if I can do that again just by putting my finger on it. Let's see if we get up to 28. 27.9. Let's let go and see if it drops again. Kind of dropping a little bit, but like not much. It's quite difficult when it's that hot to affect it. I think it's because it's been running for a little while. I think the Raspberry Pi next to it's also quite hot as well. So there we go. We can see receiving temperatures and sending that over Bluetooth to us. So that's pretty cool that example did work as well first time. I'm going to go back to that first example. I wanted to just see why that wasn't working. So I'm going to go over here. I'm going to stop the code with Control-C. Feel free to ask any questions in the chat as well. I'll come back to those. I'm just going to go over to lesson 1. I'm going to stop that from running. I'm going to pick up lesson 1, run that there. Go over to here and run this. Just wanted to see if we could get that example working. It's quirky that sometimes it seems to work and sometimes it doesn't. Not very helpful on a live stream. No, it's just timed out again. So what I have found is like a troubleshooting method. If we go back over to Thonny, I'm actually just going to quit Thonny completely. So let's just go quit. And then let's just load it back up again. And it does look like it's running fine, to be fair, on Thonny. Maybe it's Visual Studio. Let's run this again, just to see if we can get that working. I just wanted you to see where the example where they kind of overwrite the same characteristic. We did see that last week when we were running the example, so yeah, that also seems to be timing out. I'm going to quit Visual Studio and see if that makes any difference. There we go. It's on a Raspberry Pi 5, so it's nice and quick to respond. Let's now run Pi demo again. Let's see if that works. So connecting to, let's just make sure it's still running nicely on there. Yep. Good job this wasn't like the only demo I was doing. No, it's not working there. So yeah, never mind about that one. Okay, let's get back to our slides then. Let's see if there's anything else I needed to talk about there. So one of the things I was looking at doing, I was going to do a demo 4, which was about multiple devices, but I kind of stopped short just because this turned out to be really not trivial at all. So Bleak doesn't allow multiple connections simultaneously. And to me that seems like a real kind of shortfall. If anyone knows differently, please do come at me in the comments and let me know. But I got the... when I was doing my research on this, you can't have multiple connections. What you can do as a workaround is run multiple instances of Python. So if you wanted to have like multiple temperature sensors connected over Bluetooth, and maybe they then forward that reading on to like an MQTT broker that you can then use in your home automation and have dashboards and whatnot. If you wanted to have multiple sensors and Bluetooth, you'd have to have each one running its own instance of Python. So that's just another way of doing that. You basically just open up another terminal, just run the separate piece of code in another window. That's kind of a workaround. Just seems a bit janky to me that there didn't seem to be any other way of getting this to work. So a bit of a shortfall, I think. So if you want to get yourself some merch, you can help out the show and support the show by getting yourself one of these amazing Robot Maker hats. Keep your head warm and look really cool as well. Available in lots of different colours. And you can basically go over to kevsrobots.com/merch if you want to pick up one of these. And we have lots of other things available, such as mugs and hoodies and stuff. And if you're not on our Discord server, you can check out our Discord by going to kevsrobots.com/discord and joining there. There's lots of people helping each other out. I always love jumping in there and seeing what people are talking about. People can also share pictures of projects they're working on, pets and all kinds of other stuff like that. It's a really nice community. Bud says, buy the hats. If you want to follow me on social media, I'm on all the social medias. So I'm on Threads at Kev McAleer at threads.net. I'm on TikTok at Kev McAleer 6. I'm on Instagram at Kev McAleer. I'm at Kev's Mac on X, and I'm at Kev's Mac at mastodon.social on Mastodon. And if you want to follow me on Blue Sky, I'm at Kev's Mac at bsky.social. I didn't have the foresight to grab the same handle on all of them, as you can see there for the TikTok one. But I do post all kinds of behind the scenes things and keep you up to date with things that I'm currently working on. Cool. And you can join if you want as well. We had a new joiner this week, so we'll welcome them to the stream in a second or two as well. So if you want to do a super thanks, that's the thanks button that appears after you've clicked subscribe. That appears under the main window. If you're watching this on live now, you can do a super chat. I know that Johnny's just done one. He's been a supporter for 5 months. We'll bring that on screen in a second. And you can also buy me a coffee if you just want a one-off kind of contribution. You can do that again through kevsrobots.com/coffee. And we've got a number of supporters I want to give a shout out to, so let's bring those up now and we can thank these people individually. So Marie-Louise Mayer bought me 3 coffees in the past month, and Toxic Toad bought me a coffee. We had Roland who bought 5 coffees, which is insane. Thank you, Roland. I do appreciate your enthusiasm. Johnny Wilson bought 3 coffees, and Ryan also bought a coffee as well. And then on the Buy Me a Coffee membership side, we've got Shemi, we've got Alvaro, we have Mary-Louise Mayer, we have Jeff Johnson, Steve Phillips, Dean Corty, Marlene Brent, and Tom. And on the YouTube membership side, we've got Bello. Let me try and get this name right. So Oluwasi, is that how you say it? I think that's a Nigerian name, if I'm not mistaken. I visited Nigeria not too long ago. I went to Lagos with all the nice yellow buses and everything. Had some amazing food there. Nigerian food is like the best food on the planet. So welcome, Bello. We've got Dale from Hydro Robotics. We've got Oxrad39. We've got Littleback. We've got Ford. We have Paul. We have Johnny. We've got Hans from Cheerlights. Stephen Cross. We have John Paul Jolly. Alistair Ware. We've got Cassie. We've got Tinkering Rocks. Johnny Bates. Michael. And of course we have Tom as well. So thank you so much for supporting the channel. I really do appreciate every single one of you. Okay. And I think that is, if I go over here, everything I have for you today on the main show. So yes, at this point in the video, I know YouTube likes to recommend over here a video that it'll think you'll really like. Possibly the one from last week, possibly another one, depending when you watch this, because I might have done thousands of more videos by the time you watch this one. I think we're on like over 370 videos now, or something like that. If you go to kevsrobots.com, you can actually see what the number is of videos that we have actually gone live with. Let's do that now, actually, because I'm curious. I go to kevsrobots.com. This is the website that accompanies this channel, and if I go to videos and click on list of shows, that's probably a nice easy way. You can see each time I've published a video. Let's scroll all the way down and let's see what we're on now. 378 videos. There we go. So last week's was the two-way Bluetooth. This week's is the how to talk between Raspberry Pi Picos with Bluetooth. Might have to change the name of that. Not sure that works. But yeah, you can see on there we've got ideas. So if you want to check out projects to do with MicroPython, we have the MicroPython shortcut there, and all the projects that we've done with MicroPython appear on there. So you can see there, this week's is a Python one, MicroPython, so that includes on there. And we've also got free courses, so if you want to learn more about robotics and you want to know where to start, we've got a whole bunch of learning pathways to help you get up and running quickly. So if I click on the learning pathways, and they're shortcutted on the sort of navigation bar at the top, as when that loads up you'll see that. So we've got databases, Docker, 3D design, Linux, MicroPython, Picos, Python, robotics, and SMARS. We've got lots of SMARS content. So if you want to learn about robotics, for example, if you click on the robotics pathway, you'll see there's 9 individual courses to help you get up and running with robotics. So the first one is Robotics 101. That teaches you all the basics. What is a robot? What can a robot do? All that kind of stuff. That's only 12 minutes to go through. We've got Python for beginners. So if you have never touched Python in your life, you can get a nice basics with Python for beginners. We've then got MicroPython from scratch. So if you want to learn MicroPython on a Pico or ESP32, you can check out that course. We then go into MicroPython and GPIO pins, so how to talk to real-world computing with MicroPython. We then got the brachiograph tutorial. That's an example of a robot arm. Really nice and easy to put that together. Very, very cheap as well. I think it's like less than $20 to build that entire robot. There's a robot eye mechanism, so if you want to know how to do robot eye mechanisms in Fusion 360, we touch on that there. Computer vision, so how to do computer vision, detecting faces and hands and gestures. That's all in the computer vision module. That was 2 hours, that one. We've got learning ROS with me. There's a whole ROS video series as well if you're interested in that. And we've got that robot arm, how to design a robot arm with a Raspberry Pi and PCA 9685 board, which is a little board you can plug all your connectors in. You can also use one of these little servo helpers that I've created as well. So yes, learning pathways will help you get where you need to be. So at this point in the video, if you're watching this on replay, I'll say thank you so much for watching, and I shall see you next time. Bye for now.